A hybrid model of Earth's evolution, impact-driven expansion precedes plate tectonics authors Scott Young, Grok, XAI 2, one independent researcher, California, 2XAI, Twitter, abstract Earth's continental arrangement suggests a complex history not fully captured by plate tectonics alone. We propose a hybrid model where early expansion, fueled by impact-induced mass addition and volatile release, precedes and enables modern tectonic processes. In this scenario, Earth begins smaller, 3,000 kilometer radius, growing to its current size, 6,400 kilometers, following the Theia impact, 4.5 Ga, and subsequent collisions. These events lower density, 6 to 5.5 G, CM3, inflate the mantle with heat and gases, and fracture the crust into proto-continents. Expansion stretches these landmasses apart over 1 to 2 billion years, after which mantle convection initiates plate tectonics, 2.5 Ga. This reconciles the global fit of continents, evident in Atlantic and Pacific alignments, with tectonic evidence like seafloor spreading and subduction. Unlike standalone expansion theories, our model transitions to observable plate dynamics, aligning with geological and geophysical data, e.g., ancient crust, magnetic stripes. It integrates cosmic influences impacts with terrestrial evolution, offering a unified narrative for Earth's 4.5 billion year journey. We suggest seismic and geochemical tests to probe early mantle anomalies, potentially validating this synthesis of expansion and tectonics as a more complete framework for continental drift. Introduction. Plate tectonics elegantly explains Earth's modern surface dynamics, continental drift, seafloor spreading, and subduction, yet struggles to fully account for the planet's deep history. The precise fit of continents across the Atlantic and Pacific Oceans hints at a simpler, global origin, often sidestepped by tectonic models assuming a fixed radius since MOM 4. 4G, Wagner 1912, Mackenzie Parker 1967. Conversely, the expanding Earth hypothesis, while intuitive for continental arrangement, lacks a clear mechanism and fails to explain current tectonic activity. Carey 1976. Here, we propose a hybrid model. Earth undergoes impact-driven expansion in its infancy, setting the stage for plate tectonics. The Hadean Eon, 4.54 Ga, was marked by catastrophic impacts, notably the Mars-sized Theia collision forming the Moon, Canup, 2004. Standard models limit this event's role to lunar genesis, but we suggest it, alongside other impacts, catalyzed planetary growth. If Earth began smaller, its expansion could explain continental distribution, with tectonics emerging as a later refinement. This aligns with geological clues. Zircons indicating early crust at 4.4 Ga, Wild et al., 2001, and cosmic context, integrating solar system chaos into Earth's story. We hypothesize 1. Earth's radius grew from 3,000 km to 6,400 km between 4.5 to 2.5 Ga, driven by mass addition and density reduction. 2. This expansion fractured the crust into proto-continents. 3. Mantle convection then initiated plate tectonics. This synthesis aims to bridge the intuitive appeal of expansion with tectonics' empirical rigor, offering a more holistic view of Earth's evolution. Theoretical framework. Our model posits 3 phases: expansion, transition, and tectonics. Phase 1. Expansion, 4.54 Ga. Earth begins with a radius of 3,000 km in density, 6 G. 2 Earth masses, akin to Mars at 6.4 x 1023 kg. Unlike standard models, we propose Theia was volatile rich, density 3.4 G, CM3, mixing low-density mantle material into Earth while ejecting denser silicates, 4.5 GD CM3, to form the Moon. Additional impacts, potentially a fragmented protoplanet swarm, compound this, raising total mass by Boston 30%. Earth's average density drops to 5.55 G CM3, necessitating volume growth (VH/MR). A 30% mass increase with a 10% density decrease yields a 43% radius increase since VR3, aligning with a shift from 3,000 km to 4,300 km initially, with further growth to 6,400 km via internal processes. Heat from impacts, 1032 J per Canup, 2004, and volatile release, H2O, CO2 from Theia, inflate the mantle. Phase changes, e.g., olivine to less dense forms, amplify this, cracking the crust into protocontinents that spread as Earth swells. Phase 2. Transition, 4.2.5 Ga. Expansion slows as impact debris wanes and heat dissipates. The mantle, now, 6,400 kilometer in radius reorganizes hot, low dens.